This is the front view of the SEL651R horizontal layout controller. The front panel is divided into three sections. On the left-hand side is the numeric display and keyboard. In the center section, there is an array of LED status indicators, and on the right-hand side are the quick action keys that enable or disable certain functions. This control represents the current state-of-the-art in recloser controls and is being adopted as a standard. We will go over all of the important aspects of this control in detail. This is the backside of the SEL651R controller, and as one can see, provides a multitude of connection possibilities. The SEL651R also comes in a vertically arranged configuration. This has been installed in some of the most recently built distribution stations. It is paired with the G&W Viper ST reclosers. The 651R can be installed as part of a pole-mounted system shown here, or a pad-mounted system that will be shown later. This diagram shows the relationship between the various operational states of the 651R controller. The logic from here is displayed on the status LEDs on the front of the interface. This shows the 651R in its vertical configuration with its protective enclosure. The battery and connections to the reclosers are made from within this cabinet. The 651R control coordinates the sequencing between the controller and the downstream recloser. Fast and slow time curves are applied appropriately. This figure shows the sequence of timed events as the 651R goes through its normal 4-shot program to final lockout. The status LEDs on the front panel indicate the state of the action sequence. This figure shows the sequence of a fault that is immediately cleared. This is the front view of the SEL651R horizontal layout controller. The front panel is divided into three sections. On the left-hand side is the numeric display and keyboard. In the center section, there is an array of LED status indicators. And on the right-hand side are the quick action keys that enable or disable certain functions. Navigation through the menu system is accomplished via 4 arrow keys, as well as Enter and Escape buttons. The display will allow 2 rows of characters to be seen at a time. The arrow keys allow one to scroll through these menus, acting as a window to view any adjacent 2 lines of information. As you scroll down, an item disappears off the top, and a new item appears on the bottom. The information that was on the bottom line moves to the top line. Using the left and right arrows allows one to move laterally in the grid. This is the second part of the 651R menu system. As you can see, the menu system is rich with system information. This is the final portion of the menu system. Many of these areas are only of interest to those programming the control. This is a view of the 651R in its vertical configuration, showing the programmable LEDs. It is divided into a series of logical areas. This is a view of part of the 651R control horizontal configuration, which contains the status LEDs. You can see that it contains all of the status information needed to assess the current state of a recloser. This is a close-up of the quick action keys on a vertically configured 651R. This is a close-up of the quick action buttons on a horizontally configured 651R. This is an overview on the Schweitzer Engineering Laboratories 651R horizontally configured controller. It's the new standard controller that we are going to be using. It's paired up with a G&W Viper ST recloser. We'll talk about the recloser later on. All of the main control buttons are located on the right side of the controller. The trip, the close, permissive bypass, teleprotection, ground disable, remote enable, and push buttons locked. If there is a need to set up for either three-phase or single-phase operation, the 651R can be set up for gang operation or individual operation of the reclosers. If you were to push the trip button itself, it will trip all three phases, no matter what the setup. If we were to manually trip the controller, you would see indicated on the left side of the panel that all three phases are open and the three red LEDs illuminate to indicate that the recloser has been tripped. It is now in a tripped state. The trip button is the only button that does not have to be combined with the master overlock or the push buttons locked feature. In order to close this back in, you will have to use two fingers simultaneously. First, press push button locked, and while push button locked is pushed, press recloser closed. That will then close the unit. Any other buttons on the panel, such as the ground, hotline tag, teleprotect, permissive bypass, or remote enable, will also have to have the master lock or the push buttons locked button pushed at the same time as those buttons to activate the feature. If you don't, you'll not have any functionality from any of the buttons on the panel. For example, if one tries to apply the hotline tag button, nothing will happen unless you use the two-finger operation. First, the push buttons locked button must be applied, and while it is being held down, then press the hotline tag button to achieve the functionality of the desired operation. To remove the operation is the same process. The unit is now set up so that it is an individual trip. If the unit has tripped out, what one should be aware of is an indication of what phase has gone out and what state it is actually in. If one were out in the field and one of the phases had faulted out, and remembering that this unit is set for single-phase operation, the panel will identify the phase that has faulted or tripped out. The control will also show you the current system status condition. The flashing trip and close buttons tell you that one of the breaker contacts is actually open. In that state, if you wish to close that open contact, you'll be required to perform the two-fingered operation. Push the push buttons locked button and the close button at the same time, and that will reclose the switch. If there were 1, 2, or 3 of the reclosers that had faulted open, they would indicate so across the left-hand side of the panel. Hotline tag. When the hotline tag is enabled, you will get one quick operation to lock out. So for equipment protection, when you apply the hotline tag, you will not get multiple reclosings, no matter what the unit is programmed for. Permissive bypass. If this controller was set up for a generator communication connection, you would also set a permissive bypass. If then there was a radio communication failure, the permissive bypass would take the radio communication switching function out of the sequence, and the recloser would then go through its full normal functionality. From the generators going back online past this recloser, the controller will be looking for a permissive signal from them. That signal is called a DGO signal. If radio communications go down, that control link will have to be disabled. Once again, it's a two-fingered operation to enable or disable this feature. Teleprotection. Teleprotection is also another form of bypass, and it is set up in the same manner as permissive bypass, in that it can take the radio communications out of the control function. Ground disable. The only time that you are most likely to run into this functionality is through switching operations or testing procedures. The OGCC will inform you as to whether or not you have to disable the ground during switching operations. Remote enable. If these controls were hooked to SCADA, then these particular units would have radio or remote communications. To disable or enable remote communications is a 2-button operation. Begin by pushing and holding the red button's locked button, followed by the remote enable button. The normal state of the unit, if it did have SCADA communications, would be an enabled state. To disable the remote communications, press the push button's locked button, followed by the remote enable button. The scrolling screen. When you open up the control cabinet, you'll see a small green LCD screen. This display will cycle through the different functionalities of the actual control. The scrolling information on the highest level menu tells us that this unit is set for a single-phase operation mode, and that it is also set to single-phase lockout. It also indicates the settings group, the amperage that it is supplying, and the voltage that is being applied to the line. This will be helpful when you're actually installing or removing these reclosers from service. You'll be able to get an instantaneous current reading from that recloser itself. You'll be able to tell whether the controller is in a bypass state or it is in an open state. In the field, and when installing the leads on the main line, you'll be looking for a zero current reference. On the display screen, you can see that you have a continuous current reading and it is a 0, so you have no current flow. You would then be able to safely install the leads up on the main line. Then you would be able to close the bypass switch. When you close the bypass switch, you'll see a portion of the current flowing through the recloser. It will be displayed on the current display, on that scrolling window. Once you see that you have current on all 3 phases, you would then be able to proceed to open the bypass and put the unit into service. This display quickly cycles through the following information. Phase mode enabled. For this unit, it is set for single-phase operation. Lockout mode enabled. For this unit, it is set for single-phase lockout. Setting group. Currently set to Group 1. Current display. Voltage display. Second voltage display. Voltage displays. There are 2 voltage displays. The secondary voltage display is supplied from the actual recloser itself from a built-in capacitive voltage supply on the load side of the recloser. The other voltage display is for outside or external potential transformers if used. They would be applied to the source side of the recloser. If you were getting into advanced programming, such as generation connections, you would have both voltage supplies and you would be able to recognize which were there. Single-phase operation mode. The single-phase operating mode tells you that this unit is only programmed for single-phase operation. That is, it will not operate as a gang-operated unit, meaning that all 3 phases will not trip together. Single-phase lockout mode. Single-phase lockout mode refers to the situation that when this unit enters lockout condition, it will only lock out the phase that was faulted and not all 3. From the scrolling display, you can pull up individual values, such as the individual currents, different metering values, and you can actually program a lot of the functionality from the front panel. You would do this by first pressing the Enter button. It will take you to a screen where you can scroll through the options. You have the metering options, events, reclosing, Monitoring, Targets, and finally you have the control settings. You also have the functionality to be able to program this unit from the Set and Show menu and program individual items from the front panel. Let's go into an advanced setup on the scrolling screen. Upon pressing the Enter button, the screen will come up with various functionalities, such as Meter, Events, Reclosing features, Monitor, Targets, Control, Set and Show, Status, and Reset Access Level 1. In the Meter menu, if you press Enter, you can view RMS metering, Fundamental metering, Demand metering, Energy, Minimum and Maximum, and Harmonics. Once the meter menus have cycled through, the scrolling screen will return to the beginning menu of RMS metering. If one were to go deeper into the meter menus and select RMS metering by pressing the Enter button, the A phase would be identified on the screen in the upper left-hand corner, while the amperage that is actually being applied to the unit would appear in the bottom right-hand corner. The B phase would appear and the screen will indicate the individual amperage going through in RMS current. Takes us to the C phase with the RMS current displayed. Takes us to the IN or neutral, where the screen will indicate the actual supplied neutral value rather than a calculated value. The VAY voltage would be the A phase from the load side voltage supply on the actual recloser itself. Additionally, VBY and VCY, the following two screens, will give you all the voltage presence on the actual recloser itself. The next down arrow button takes us to VAZ, the letter Z referring to external potential transformers. If supplied, this would give you a rated value in the bottom right-hand corner of the screen. The next meter readout is MWA. That refers to the megawatts of the A-phase amperage. MWA is followed by MWB and MWC, and finally MW3P for the three phases. This concludes all the metering needs, all of which are accessible through the front panel. To escape from the metering menu and return to the main menu, simply press the Escape button once. This will return you to the RMS metering screen. Press the Escape button again, and it will return you to the main metering screen. Press it once again, and it will return you to the initial scrolling screen. The next menu in the scrolling screen after Meter is Events. To arrive at this menu, one must press the Enter button upon seeing the main meter screen. This will stop the screen from scrolling and remain at the Meter menu. To move to Events, press the down arrow. Events will be populated by anything that actually trips the recloser open. Pressing Enter will show Display Events. Pressing Enter again, the screen will give you the date and time of the last event. The system can have 50 events stored in the log. When those events fill up, the log will rewrite from top down. In other words, the most recent event will be the first one that displays. Pressing the Enter button again will allow you to scroll through the events using the up and down arrow keys. Once an appropriate event is selected, press Enter, and then the down arrow key will show you the type of the event. In this case, it was a manual trip. If you press the down arrow again, the location of the event will be displayed. In this particular case, we see nothing but dollar signs, which means that if you do not have external PTs and internal PTs for the distance location, you'll have to physically search for the distance to the fault, otherwise it would be provided. Pressing the down arrow again will indicate what the actual amperage was when that particular trip occurred. Pressing the down arrow key again will give the B phase current. The next down arrow stroke reveals the C phase current, followed by the G, which is the calculated value. The next down arrow screen displays 3I2 that indicates the negative sequence current. The next down arrow menu displays the frequency at that trip. Finally, the last screen will indicate what group setting that you are using. To return to the initial window of logged events, press Enter to navigate to any of the 50 logged events in the system. If you want to select the next event down, press the down arrow key to highlight the event. The screen will now show two events, the one at the bottom being the second last operation. Again, if you hit Enter on the selected event, you can now go through the same procedures as you did for the very first event. An easier way to review this is to have an actual download of the events and histories. But for a quick reference on site, you can go through this manually and examine the individual event displays. To get back to the main menu, hit Escape twice. Now we're back into the main scrolling window. If we press Enter, we are into metering values again. The down arrow takes us to Events, and when pressed again, we arrive at the Reclosing menu. We press Enter, and we can see the unit is set for 3 recloser attempts. When the unit is set for 3 recloser attempts, you have 4 shots until lockout. The first operation will be counted as 1. The second operation will be counted as 2. The third operation will be counted as 3. It will not reclose after the fourth operation. There is what is classified as a 2-second dead time. What that means is when that fault occurs and the unit trips open, there will be a 2-second dead time before it will reclose to try that operation again. If the fault is still there, it will reclose into that fault and it will then trip out again. There will be a 2-second dead time, and it will continue this process until the number of recloses that it is set for is reached. If you press the down arrow key, the screen will indicate the recloser count on the A phase. If you press the down arrow again, you will see the recloser count on the B phase. Pressing the down arrow button again will take you back to the initial recloser resets, indicating the number of operations until lockout. Those operations are operation counters per phase. The 3 A, B, and C screens show us how many operations have been on each individual phase. Pressing Escape twice takes us back to the scrolling screen. If we press Enter, and then the down arrow, we arrive at the Meter Events submenu. Pressing Enter on the Reclosing Monitor menu will take us into Breaker Data. Pressing Enter again will indicate the amount of internal trips on the A phase. If this unit were out in the field, this screen would indicate the amount of trips that this unit has actually gone through. In our testing procedures, you can see that we have gone through quite a few. Pressing the down arrow again shows us the current applied on the A, B, and C phases. The next menu indicates the external trips for the A, B, and C phases. The following three screens indicate external trips for the A, B, and C phases measured in kiloamps. The next screen displays the contact wear monitor for the A phase. The indicator begins with 100%, and as it wears, that percentage goes down. The wear indicator refers to the internal vacuum contacts in the actual recloser. Contact wear is good for 10,000 operations at the minimum threshold of these units. These units are good for 600 amps. So if one were to have 600 amps applied to this and every fault was right at 600 amps, that contact wear life would be 10,000 operations. If the amperage is increased, the calculation takes that into effect. So if you were to put 2,000 amps through this, it would take a percentage of the amperage that went through on that operation, which in turn would increase the wear monitor. There is a mathematical equation that is set into the actual control, so it knows the actual duty of that contact based on the magnitude of the fault that was applied. So if you had all minimum trips that were just at the threshold, this unit will perform up to 10,000 operations. Press Enter to escape. This will return one to the wear monitor A. Pressing the down arrow will scroll through wear monitors B and C. As seen here, most of our faults have been applied to one phase for our testing purposes. Other phases were tested for functionality and balance verification. Press Enter to escape and return to the main scrolling screen. Press Enter to access the meter screen. Now, using the down arrow key, scroll to Targets and press Enter. The row and target number are displayed. Using the down arrow again, we'll scroll to row 2. Referring to the reference manual will provide a target explanation in addition to what element has been picked up to trip this recloser. Press Enter to return to the scrolling screen. Use the down arrow to select Control. Press Enter. This displays local bits. Scroll down for Output Contacts. Press Escape and use the down arrow to select Set Show. This feature allows basic programming from the command screen. While Set Show is selected, press Enter. This will display Group. There are 8 possible group settings. In the distribution world, it will typically be Group 1. There might be some advantages in generation connection that may allow for Group 2 to be programmed. With Group 1 selected, press Enter. This scrolling screen will now display the desired settings. In this case, identifier settings and instrument transformer settings. Press the down arrow. You may now enable those settings by pressing Enter. Any changed settings may be saved. Press the down arrow to select Line Parameter Settings. This feature allows you to set the qualifications for the distance to fault, etc. These functions would be set from a laptop by P&C staff. On the top of this unit is the green Enabled indicator. This indicates that the recloser is set up and enabled for automatic recloses. The trip indicator will turn red when the unit has been tripped out, manually or otherwise. The supply indicator will remain green as long as an AC supply is present. The battery problem indicator will turn red should a battery problem occur. The batteries are automatically tested every 24 hours. The A fault, B fault, and C fault indicators will turn red should a problem occur on those phase reclosers. These could light up in any combination depending on the nature of the fault conditions. Ground fault will indicate that you have picked up a fault on the ground. Since there is not a ground CT, ground indicates an imbalance between phases, such as a high fault condition, phase to ground. Fast curve. This will indicate during the time that the unit is performing a reclosing operation on a fast curve. Delayed curve indicator. This will illuminate while in a slow curve tripping sequence. These controls can be programmed from 1 to 4 operations until lockout. Typical in distribution is 4 shots till lockout. Instantaneous overcurrent. This light will indicate upon tripping on instantaneous overcurrent. This setting would be typically set for 1 shot till lockout. This feature is usually not set for these controls. High current. This will indicate upon tripping on a high current. This feature is typically not programmed in the distribution system. Cold load pickup. This unit has a second set of settings, which can enable a cold load pickup. After lockout has occurred and reclosing is taking place, enabling this function will allow more load to be carried without causing another fault until the system current balances out. When first picking up on a cold load situation, such as a line being out for more than 15 minutes, you will have an increased current surge due to a loss of load diversity. This LED will show you that cold load pickup is active for the programmed cold load duration. 79 reset. This green LED indicates that the control has reset and is ready to perform its full operation cycle. 79 cycle. This indicates when the unit is performing its operations. While switching between operations, the light will turn red. Red, white, and blue phase lockout LEDs will turn red upon lockout of these phases. When set for single-phase parameters, any combination or all of the indicator LEDs could be illuminated. The next 6 indicators are the voltage input indicators. There are 3 internal voltage indicators from the recloser and 3 voltage indicators from the external phases. Any of these will indicate red whenever a voltage presence is lost. We will provide a brief overview of the action buttons and their functionalities. Ground disable. This is typically used in switching operations or testing procedures. This is a 2-button operation. Press both the push buttons locked and ground disabled buttons simultaneously. The ground disabled indicator will turn yellow. Repeat this operation to reapply the ground. Remote enable. This is used for remote SCADA communications. This is also a 2-button operation. Press the push buttons locked and remote enabled buttons simultaneously to remove this feature. The following 3 buttons are not programmed. These can be used for future programming. Hotline tag. This is used to set the control and recloser for one fast operation to lockout. This is for equipment protection. To apply this, push both the push buttons locked and hotline tag buttons simultaneously. The hotline indicator will turn amber. Were this to trip out under a hotline tag condition, as demonstrated here, the unit cannot be closed until the hotline tag is removed. This is done by again pressing the push buttons locked and hotline tag buttons simultaneously. Teleprotection enabled. To enable communications for distributed generation or DG operations, press Master Push Buttons Locked and Teleprotection Enabled simultaneously. Permissive bypass. If radio communications fail, the control will be searching for a phantom return signal from the generator. In order for the control to be able to respond to a fault condition, the permissive bypass must be active. When active, the control will enable itself to respond to the fault condition in the absence of the communications link, and permissive bypass simultaneously to allow for full functionality without a generation communication connection. Trip. This button is programmed for a one-button operation and will trip out all three phases regardless of whether or not the control is programmed for single or triple phase fault lockout. To close, press both push buttons locked and close. The AC for this control comes in through the main breaker seen here. Were this breaker to trip open, this switch would be in the down position. The unit is now still active, but is being supplied from the rear DC battery. As long as a healthy battery is connected, the unit will be active for 24 to 36 hours, depending on weather conditions. To reapply the AC, switch the breaker back to a closed or up position. Under the ABB cover plates, shown here on the bottom, are separation flex test switches that will isolate the two voltage supplies, current supplies, and certain communications elements. These are in a covered state to avoid accidental activation. These are strictly for testing procedures. Above that is the satellite clock input. When set up in the field, this unit will be time-controlled from a satellite clock. Analyzing events. Reports. All reports are stored in non-volatile memory, ensuring that a loss of power supply to the SEL651R module will not result in lost data. Each time the recloser control generates a standard event report, it also generates a corresponding event summary. Event summaries contain the following information: recloser control and terminal identifiers, date and time when the event was triggered, event type, fault location, recloser shot count at the start of the event report, system frequency at the start of the event report, front panel fault targets at the time of trip, phase IA, IB, IC, ground, and negative sequence current magnitudes in amps primary measured at the largest phase current magnitude in the triggered event report. The recloser control includes the event summary in the standard event report. The identifiers, date, and time information is at the top of the standard event report, and the other information follows at the end. The event field shows the event type. The event type designations AG through CAG are only entered in the event field if the fault type is determined successfully. If the fault type is not determined successfully, just trip or ER is displayed. Fault location. The recloser control reports the fault location if the EFLOC setting equals Y, and the fault locator operates successfully after an event report is generated. If the fault locator does not operate successfully, or if EFLOC equals N, then $6 are listed in the field. Fault location is based upon the line impedance settings and the corresponding line length setting. The fault locator will not operate properly unless three-phase voltages are connected. The fault locator is most accurate when the fault currents last longer than 2 cycles. Do not use the phase-over current elements for load current detection if the fault locator is enabled, That is, the setting EFLOC equals Y. Set these elements above load current levels so that the fault locator will work correctly. Use the 50L element instead for load current detection. Do not use the ground and negative sequence over current elements for load unbalanced current detection if the fault locator is enabled. Set these elements above the load unbalanced current levels so that the fault locator will work correctly. Shot count. When three-phase reclosing is enabled, the SEL651R reports the recloser control shot count present at the start of the event report. When single-phase reclosing is enabled, the SEL651R reports the highest recloser control shot count present at the start of the event report. When the recloser control is defeated, the shot count field will contain a blank. This is an example of the event history from the 651R when downloaded. Looking at Event 1, you can see that it was a BG event at a distance of 3.02 miles. For the second event, you can see that it was a manual trigger, so no distance is recorded, and the current was less than the fault trigger setting. You can also see the active group setting and other pertinent data. In the manual, there is a definition list of the abbreviations shown in the event reports. The printout from the events for the 651R provides detailed information on every critical aspect. The 651R provides either 15 or 30 cycle reports, depending on the configuration. This is a close-up of the two-line display window and how it functions by scrolling to view the contents of the menu. The cursor is under the active item. Moving the cursor down will cause the top line to roll up and out and a new line to roll into the display window. The item that was on the second line now moves up to the first line. This shows you that by using the right arrow function, you can scroll across to get to a new menu or continue down an existing menu. This is a view of the 651R in its horizontal configuration within its protective field enclosure. This is a view of the 651R in its vertical configuration within its protective field enclosure. This is an excerpt from the 651R manual that shows the type of reclosers with which the 651R is pin compatible. For new installations, the 651R is being paired with the G&W Viper ST. The 651R controller display screen under normal conditions will scroll through various items such as the mode. In this case, single-phase lockout is enabled. The currents, the DS name, the setting group, the amperages, and finally, the voltages. Below the display screen are the arrow selector buttons and the enter and escape buttons. Pressing the enter button will allow you to scroll through a series of screens such as meter, events, reclosing, monitor, targets, control, and settings, which allows you to change the functionality of the recloser. The only screen that a lineman will really be interested in is the events. Let's take a closer look at events. Scroll to Events and then push the Enter button. This will take you to Display Events. Pressing Enter again will display the most recent operation, including a date and time. Pressing the right arrow button will allow one to scroll through an event. Pressing the down arrow will allow you to cycle through a possible 50 events. Scroll down to see Type, which tells one the type of fault that occurred. In this case, it was a manual trip. Press down again to see Location. If programmed, this would display the distance to fault. This feature is not programmed in 90% of controls and will return a result with number of $signs. Pressing the down arrow key will display the A-phase current and according fault condition if it exists. Then the B-phase current and according fault. Next, the C-phase and according fault. And G or ground current and according fault. In the case of this example, it was not a fault condition but rather a manual trip by us. No amperage was displayed in the screen. Press the Escape button to return to the main scrolling screen. This is a brief overview of the status LEDs and their purpose. Supply. If the AC was connected and on, then this LED would be green. Battery trouble. If the batteries were in need of repair or replacement, this LED will illuminate red. Next are the 4 individual phase fault indicator LEDs, A, B, C, and the ground, which illuminate to indicate which phase and/or ground have activated the trip. Below this are the fast and slow trip LED indicators. Only the active timing curve LED will illuminate while the recloser is functioning under a trip condition. In the middle, we have an LED for a high current fault condition. This is currently not programmed into the controls. Were it programmed and it tripped on a high current, this LED would turn red. Below this is the frequency fault indicator LED. This is not programmed into the control. Phase discordance is not programmed into the control. Were this to trip on phase discordance, the LED would become red. Next is the 51 trip sequence indicator LED. This will illuminate red as the recloser cycles through its tripping sequences. 79 reset will be green when the control has reset and is under a normal operating condition awaiting a trip condition. Below this is 79 cycle. This LED will be red whenever a trip is in process and stay on until the control has reset. Phase cold load and ground cold load are currently not programmed into the control. These would become red when this function becomes active. Along the right side are the 52A A phase, 52A B phase, and 52A C phase indicator LEDs. These will be illuminated green when the recloser is in the normally closed state. Next are the lockout indicator status LEDs. LO A phase will turn red, indicating a lockout state in the A phase. LO B phase will turn red, indicating a lockout in the B phase. LO C phase will turn red, indicating a lockout in the C phase. Any combination of these may be illuminated for a fault condition. These will be activated by the type of phase downstream. For example, a phase-to-phase would illuminate 2 of the LEDs. LO manual. This LED will turn amber should the manual handle fall or be pulled down on one of the reclosers. Trip fail. Should the recloser fail to operate, this LED indicator will illuminate red. On the far right side is the green enabled indicator LED. This tells us the unit is enabled and ready to function. The trip LED will turn red if the recloser trips out. Finally, the target reset button will test all LEDs and reset the target conditions. There are 12 push buttons on the bottom of the control that function as pre-programmed action buttons. Ground enable. In order to turn off the ground to avoid the recloser from tripping on a ground function, press the ground enabled button once. Push again to turn the ground back on. This is typically used in switching operations. Reclose Enable. The recloser will go through all of its programmed shots to lock out. The LED will be amber when this function is on. Pressing the button deactivates this. The amber light will turn off, and you now have one shot until lockout. Press the button again to reset. Remote Enabled. Pressing the Remote Enabled button will enable remote communications from the Ontario Grid Control Central, or OGCC. Press again to disable communications. Spare. This button is presently not active. It can be programmed for different features depending on the need. Fast Curve Enabled. Pressing this button will activate the Fast Curve Lockout cycle. It is red when it is enabled. Push buttons locked. Pressing and holding this button for 3 seconds, and after it stops flashing, will lock all of the features on the control, except for the trip feature. The LED will turn amber at this time. This should normally be in the off position. Press and hold the button for 3 seconds again to deactivate or turn off this feature. Hold off. This is the American term for our hotline tag. To activate the hold off requires a 2-button operation. Push and hold the master button while also pressing the hold off button. When the hotline tag is enabled, the recloser will execute a single fast curve to the final lockout state. The Reclose Enable indicator LED will turn off, confirming that a single shot to lockout will occur. There are 2 spare buttons on the right side of the unit. These are currently not programmed. Finally, we have 2 buttons: the Recloser Closed, which is currently green, and Recloser Open Trip button. In order to change the state of the recloser, you must push the master button and the trip button simultaneously. The recloser will now trip open. The LED will turn red. To close it back in, push the master and the close button simultaneously. The reclose LED will turn green. Changing the recloser to an open state is a 2-button operation. Push the master button and the trip button together. The unit will trip open and the open indicator LED will turn red. Above you will see the 3 phases have locked out and all of the 3 LEDs have turned red. Closing the control back in is also a 2-button operation. Push the master and recloser closed button together. The state will change from lockout to closed. The control will revert to a 79 reset state. It is now capable of full functionality. The Reclose Enabled button will deactivate the normal multi-shot reclose process if it turned off. This means that the recloser will operate with 1 shot until lockout. This is not to be used as a hold-off substitute. It is for testing purposes only. To re-enable the normal multi-shot reclosing process, press the Reclose Enable button so that the amber LED will light up. Applying the hold-off, or in our terminology, a hotline tag, requires a 2-button operation. Push the master and hold-off buttons together. The Reclose Enable light will also turn off. With the hold-off engaged, the system will respond to a fault or manual trip with a 1-shot lockout. For demonstration purposes, we will manually trip the unit. When the recloser has tripped out under a hold-off condition, the recloser cannot be closed until the hold-off has been removed. You will notice that after pushing the master and recloser closed buttons together, the recloser does not close. To turn off the hold-off, press the master and hold off buttons together. Recloser enabled will become active, and you will now be able to close the recloser. If the recloser has tripped out and the red manual lockout LED is on, you will be unable to close the recloser. This will occur if the manual operating handle has either dropped or been pulled down. You'll also notice that all three of the phases are in a lockout state, and their LEDs are red. Now, to close this unit, you must open the cabinet containing the actual reclosers and close in the yellow manual operating handle, which will be in the open or down position. After successfully closing the manual operating handle, the red light will turn off. You can now close the system using the master and close buttons. All three of the phase indicator LEDs and the 79 reset LED on the panel turn green, and the system is now in its normal operational state. 351 front panel push button operation. Most of the push buttons have dual functions with primary and secondary functions. Primary functions. A primary function is selected first. For example, the meter push button. After a primary function is selected, the push buttons then revert to operating on their secondary functions of cancel, select, left arrow, right arrow, up arrow, down arrow, and exit. For example, after the meter push button is pressed, the up arrow and down arrow are used to scroll through the front panel metering screens. The primary functions are activated again when the present selected function, or metering, is exited. Press Exit push button. Or the display goes back to the default display after no front panel activity for a settable time period. Secondary functions. After a primary function is selected, the push buttons then revert to operating on their secondary functions. Use the left arrow and right arrow to underscore a desired function. Then press the Select push button to select the function. Use the left arrow and right arrow buttons to underscore a desired setting digit. Then use the up arrow and down arrow to change the digit. After the setting changes are complete, press the Select button to select or enable the setting. Press the Cancel push button to abort a setting change procedure and return to the previous display. Press the Exit push button to return to the default display and have the primary push button functions activated again. The Press Control for Local Control message displays in rotation with the default metering screen if at least one local control switch is operational. It is a reminder of how to access the local control function. Meter. The meter command shows the AC currents and voltages, magnitude and phase angle, which are presented to the relay in primary values. In addition, the command shows power system frequency and the voltage input to the relay power supply terminals. Compare these quantities against other devices of known accuracy. The meter command is also available at the serial ports and front panel display. Auto reclosing. The SEL 351 can auto reclose a circuit breaker up to 4 times before lockout. One can use the SE logic control equations to program the SEL 351A to perform the reclosing functions. The recloser shot counter controls which protective elements are involved in each reclose interval. Applications include fuse and trip saving schemes. The front panel LEDs Reset, Cycle, and Lockout track the recloser state. Fault locator. The SEL 351A provides an accurate estimate of fault location even during periods of substantial load flow. The fault locator uses fault type, replica line impedance settings, and fault conditions to develop an estimate of fault location without communications channels, special instrument transformers, or pre-fault information. This feature contributes to efficient dispatch of line crews and fast restoration of service. The fault locator requires 3-phase voltage inputs. The fault locator does not operate for ground faults on ungrounded, high-impedance grounded, or Peterson coil grounded systems. Also, the fault locator will not operate properly unless three-phase voltages are connected. The fault locator is most accurate when the fault currents last longer than 2 cycles. The relay reports the fault location if the EFLOC setting equals Y, and the fault locator operates successfully after an event report is generated. If the fault locator does not operate successfully, then $6 signs are listed in the field. Event reports. The SEL 351 offers 2 styles of event reports: a standard 15 or 30 cycle event reports, or a sequential events recorder or SER report. Each time the relay generates a standard event report, it also generates a corresponding event summary. Event summaries contain the following information: relay and terminal identifiers, settings RID and TID, date and time when the event was triggered, event type, fault location, recloser shot count at the trigger time, system frequency at the front of the event report, front panel fault type targets at the time of trip, phase, IA, IB, IC, neutral ground, IN, calculated residual ground and negative sequence current magnitude in amps primary, measured at the largest phase current magnitude in the triggered event report. The event report summary shows the magnitude of the maximum phase current calculated by the cosine filter or bipolar peak detector. When the relay uses the bipolar peak detector value, the relay displays PK. This is a basic overview of the SEL 351 control that, in this setup, is being used with a Jocelyn VBM44 recloser. First, we'll review the function of some of the selection buttons. Target reset. Pressing this button manually resets all of the target conditions. When you close the recloser back in after a fault, the targets will reset as well. Next is the meter button. Pressing this button will display all of the amperages. Next, we have the events button, which will display the most recent event, including the date and time that the fault occurred. After pressing any of these selection buttons for the first time, the second row of symbols below those selection buttons redefine function of the buttons directly above each symbol. For example, pressing the Other button at this point will cause it to act as a redefined right arrow. The display will now scroll across to the right, showing us the fault information, which in this case tells us that it was tripped. Press the Other button again for it to function as the right arrow button. The control will only display the actual fault location if you have both voltage and current supplies, and it is programmed for this function. Otherwise, what will be displayed will be dollar signs. Pressing the Other button or right arrow again will display the A and B phase amperages. Pressing Other again will display the C phase and the neutral amperages. These data are used to determine which phase caused the actual trip. To back out of any of these selections, press the Exit button, which is the redefined group button, and you'll be returned to the main default screen. At the primary level, the Status button is just used to display the type of control and the serial number. At the secondary level, it functions as the left arrow button. Again, to back out of the Status selection, simply press the Group button that has been redefined to function as the Exit button. The high-level function for the Other button allows you to select the date. You'll see an underscore under the date. Now, after pressing the Select button, which is the redefined Events button, you can either set or cancel a value. Using the arrow keys, Move the underscore to Set, and once again press the Select button. You are now free to set your actual date using the arrow keys to select the month, day, and year. Again, pressing Exit will reset our selection. The next selection is the Set button. Pressing this will allow you to program all the advanced features. Since most linemen will not be using this advanced feature, let's move on to the Control button. The Control button is used for input and output contact testing. This is also an advanced feature and is used for testing of the control itself. It is not a function that would be used by a lineman. Now let's explore this next set of features located just below the selection buttons. First, we have Control Enabled. The green light tells us the control is enabled and ready to function. Next is AC supply, which is also green. This means the unit has an AC supply. Should a battery problem occur with this unit, such as the battery depleting itself under a loaded condition, the battery problem light will turn red. This unit performs its own internal tests once every 24 hours. The hotline tag indicator will turn red when a hotline tag, or as it is also known, a hold-off, is applied. Next, we have the trip indicator LED. If the unit has been manually tripped or tripped out automatically from a faulted condition, the trip light will illuminate red. If this unit is actually operating on a fast curve, the light will turn red. In that state, as it recloses, it will turn from red to clear. If the high current setting was applied to the control, this indicator would turn red if it tripped on a high current fault. The 81 indicator is not used in any of these controls. Moving down to the next level of indicator LEDs, we have Reset, Cycle, and Lockout. In the lockout state, all three phases are open and locked out, while in the cycle state, waiting for the next operation, the cycle light would also be on. Moving on to the Reset indicator LED, when the recloser has closed, it will change to the state after the programmed time of approximately 10 seconds. The next three status indicators are the A, B, and C phase fault current indicator LEDs. These indicators will illuminate to indicate on which actual phase or phases that the fault occurred on. Next is the ground LED. There is no ground on the VBM44 recloser, so this picks up any imbalance between the phases. If there is a significant imbalance that meets the threshold setting in the control, that light will also activate. Finally, we have the SEF, or Sensitive Earth Fault Indicator LED. This feature is not used in this control panel. Below the status LEDs are another set of push buttons. First, we have the Ground Enabled button. To turn off the ground, press this button and you will see the amber light turn off. The ground is now disabled. Press this button again to enable the ground. This is typically for testing and/or switching procedures. The Reclose Enable button is normally on and is used if you want the control to go through the entire cycle of programmed reclose attempts. This light is amber when active. To go to only a one-shot to reclose cycle, press the button again. The amber light will now turn off. Next is the Remote Enabled button that is activated when connected to remote communications. Presently there are none available, But in the future, remote-enabled will be established, providing communications between the control unit and the OGCC. To activate this feature, press the button and the light will now be amber. Pressing it again will disable it, and the amber light will turn off. Alternate settings. If this control had two setting groups applied, pressing the Alternate Settings button would activate the second set of program settings within the control. Pressing the button once more will return to the first default group settings. Next is the lock button. If the control was set to, for example, a hold off or had alternate settings enabled, pressing down the lock button for 3 seconds will lock all buttons on the control, except for the trip button. This is a safety feature. While locked, all attempts to change the state of any other feature will be unsuccessful. To remove the locked state, once again press and hold the lock button for 3 seconds. The amber light will now turn off, and you will now have full functionality of all of the push buttons. Next, we have the hotline tag or hold off button. After pressing this button, its light turns amber, and the hotline indicator LED turns red. We now have a hotline tag or hold off condition on the line. The control will now only operate one shot until lockout using the fast time curve. To remove the hotline tag, press the hold off or hotline tag button again. Both the red and amber indicator LEDs will now turn off. Lastly, we have the trip and close buttons. The closing process utilizes a mechanical spring-driven closing mechanism. After pushing the close button, you will see the LED light begin to flash green. You will then hear the sound of the motor beginning to charge the trip springs and close the contacts. The close button indicator will now turn green. To trip the unit, press the trip button. This will instantly trip the unit open, and the open indicator LED will now turn red. The trip LED will also illuminate red. It is possible to set the hold off with the contacts open. However, the unit cannot be closed with a hotline tag or hold off in place. Pressing the button in this state will not close the unit. If a hotline tag is active, it must be removed before the unit can be closed. This feature is meant for personal protection. If the unit were tagged, the operator could only remove the hold-off by surrendering their permit on the line. This would then legally allow them to remove the hotline tag and close in the unit. A note about the high current and the normal trip current setting. If you were setting the normal trip current value in this unit, you would set it for a threshold that would coordinate with downstream devices. On the other hand, high current is typically set when a unit is placed very close to a station where the fault currents available at that location are above your desired threshold setting. If the high current value is exceeded, you get an instantaneous one-shot to lockout trip, regardless of the settings. You do not want the unit to follow a cycle of multiple reclose attempts. For example, if this unit were 10 kilometers away from the station, the maximum fault current available at that location might be 2,000 amps, well within the threshold of this unit, allowing it to maintain that state for a longer time period. The maximum amperage rating for these units is 3,000 amps. If the unit were too close to the station, not having the high current setting on would affect its ability to trip to final lockout as quickly as possible and minimize any damage to the recloser. Setting the high current in the control will cause it to immediately lock out if the continuous current reached above the 3,000 amp threshold. At the bottom of the enclosure, we have the battery backup system. There are two 12-volt batteries in series providing a total of 24 volts. If the AC is lost to the controls, the batteries will hold the unit's functionality for up to 24 hours. As you can see from the warning notice, always connect the battery before turning on the AC supply to the control. Let's review the display features as we look at the default screen. This screen displays both amperage as well as the number of trips on this unit. Pressing the Event button will display the most recent event, including date, time, and amperage. In this case, a manual trip or a block of the actual reclose. You can move to the next event by pressing the down arrow. Proceeding down farther will display exactly what's happened for each one of the events. Starting from the default menu, pressing the Settings button will show the settings programmed into this control. This particular unit has been programmed for 300 amps. Scrolling down again will display the curve for the fast curve, in this case an A curve. The time dial for that would also be an A curve. The second curve, or the slow operation displayed here, is a B curve, along with a B time dial. You can see this unit is built to withstand up to 6,000 amps. Beyond this point is advanced programming. Three-phase lockout. Three-phase or ganged lockout allows PowerMax controls to be connected together so that if one control goes to lockout, the other connected controls will open their respective tri-mod recloser. When PowerMax controls are connected together, each individual control and tri-mod recloser operates based on its own pre-programmed settings. Therefore, when each system clears a temporary fault, the other phase or phases are unaffected because only that tri-mod recloser will open and reclose. If the fault is permanent, the PowerMax on the particular phase will go to lockout and issue a command for the other connected PowerMax controls to open. Only the faulted phase or phases will have lockout indication. The other controls that were commanded to open via the three-phase lockout will only show open indication. Therefore, the faulted feeder can easily be identified. When PowerMax controls are connected together and the manual trip to lockout feature is on, manual opening of one tri-mod, whether by the open push button in the control or by the manual operating handle on the tri-mod, will result in all connected PowerMax controls opening their respective tri-mod. This is an overview of the Jocelyn PowerMax 100 recloser control and the Jocelyn tri-mod recloser. First, let's look at the basic functional control buttons. Seen here are your standard red close and green open buttons. Open. Pressing this button with the recloser closed will cause the control to open the recloser and go to lockout. When the recloser is open, the green LED will be illuminated. When the control is in lockout, the yellow lockout LED will be illuminated. Pressing this button with the recloser open will cause the control to close the recloser. When the recloser is closed, the red LED will be illuminated. Lockout conditions will be reset when this button is pressed. There is an intentional blocking between manual closing operations of approximately 5 seconds to prevent excessive duty on the control. This delay has no effect and does not limit reclosing operations. Both the open and close LEDs will be illuminated at the same time when the recloser is not connected to the control. Next, in the older controls, we have Reclose Enable, which is also your hotline tag feature. Below that is the Remote Enable, which is typically not used because it's for SCADA communications or remote applications, where this unit would be controlled by a remote operator. Next, we have the default menu button, a settings button, an events button, as well as a scroll arrow up and a scroll arrow down. These will allow you to scroll through the different applications, which will be displayed on the screen. The normal default information on the screen is the amperage that is flowing through the unit and the number of trips that this unit has gone through. Press the default menu button at any time, and this will return you to the default screen. Pressing the Events button will display the most recent operation. This screen, for example, shows that the most recent operation was a manual close. Had this been a faulted condition, the actual fault records would be displayed. To leave the Events display, press the default menu button. To display the settings, press the Settings button to display exactly what the pickup is programmed for, in this case 300 amps. Now, by pressing the scroll arrow down, you can see that the fast curve for this unit is an A curve. Press again to display the second or slow curve, in this case a B curve. Press again to display instantaneous pickup. This particular unit is rated for 6,000 amps maximum current flow. And finally, press again to display instantaneous delay. This feature allows you to program a delay if so desired. The settings past this are not really of interest to a lineman. Panel lock. Pressing the panel lock button will block all front panel commands except the open button. The button must be held for 4 seconds to change lock status. When the control is locked, the status will appear on the LCD display. The red indicator LED on the Close button tells us that this unit is closed. To trip this unit open, press the green Open button. The indicator will light up green and the lockout indicating LED will illuminate. To close the unit once again, press the Close button. The close indicator will light up red and the lockout LED will go off. Under normal conditions, the Reclose Enable LED would be on. This will allow it to go through its normal operations for whatever it is programmed for to reach lockout. If you wanted a hotline tag or hold off to allow this to go only one shot to lockout, on the older panels, you would turn off the Reclose Enable. More recent panels feature a pre-programmed button marked Hotline Tag, located roughly here on the newer panels. This is the display screen, and it provides a significant amount of important information, such as the battery condition, SF6 pressure, the status of the AC power supply, and other critical parameters. When changing the status of a feature, one can follow the sequence via the display. When you press the Custom Menu button once, you get the switchgear status screen. Pressing it again takes you to the Event Log screen. Pressing it for a third time will display the Current screen. It will give you the current for each phase. To return to the main menu, press the Menu button a number of times until you reach the main menu screen. This is a brief overview of the ADVC recloser controller. There are actually two variations, the ADVC1 and the ADVC2. Let's begin with the ADVC1. Upon opening the main door, you will find the main processor. It has the words Advanced Controller on its cover. Below the main processor, you will find the batteries. Resting beneath the batteries are 3 breakers, one for the battery, one for the voltage supply, and the main containment breaker for the entire unit. Also housed within the unit is an outlet for the gray-colored communication cables, which connect to the recloser. These are plugged directly into the main processor. The controller interface is accessed on the outside of the panel door. The ADVC controller reads and displays the information stored in its attached switchgear. It also trips and closes the switchgear for the primary purpose of protection. The ADVC consists of an electronic switchgear controller known as the Control and Protection Enclosure, or CAPE, that monitors the switchgear and provides protection and communications functions. An operator interface mounted on the Control and Protection Enclosure inside the cubicle. A power supply which also supplies power for customer equipment. Accessories and customer equipment compartments, varies with model, is powered by an auxiliary voltage supply of 110, 220, or 240 volts AC, is connected to the switchgear via a detachable control cable. The ADVC controller cubicle is constructed of stainless steel and is insulated and designed to minimize any temperature rise resulting from solar heating. The operator interface is located on the CAPE inside the cubicle door. The cubicle door is sealed with a rubber extrusion, and the cubicle vents are screened against the entry of vermin. If installed, a hatch provides access to the operator interface without opening the cubicle door. The controller electronics incorporate the functions of an overcurrent and earth or ground fault protection relay, an auto reclose relay, and a remote terminal unit. Additionally, the electronics can measure line current, voltage, real and reactive power, fault currents, and harmonics, and perform waveform capture. These data are stored for transmission or offline analysis. The ADVC contains a built-in microprocessor-controlled power supply that provides uninterrupted operation of not only the switchgear and protection relay, but also the communications radio or modem. The ADVC reads and displays the switchgear-related information that is stored in the switch to which it is connected. Therefore, if the ADVC is moved to another switch, it reads the data from that switch. The ADVC customer compartment provides room for other equipment. Standard communications cables can be used for connection to the communications ports on the CAPE, and power is readily accessible from the power terminal block located on the customer compartment. The compact cubicle has 1 customer compartment, while the ultra cubicle has 2. The ADVC can be remote controlled via modems or other communications devices, controlled using a laptop computer connected directly via serial or USB connections to the ADVC, or by the operator interface. The operator interface offers full functionality to change settings, trip and close the switchgear, or display current values or past events related to the switchgear's function. The operator interface is mounted on the CAPE inside the ADVC controller and accessed by opening the cubicle door. It consists of a liquid crystal display and keypad and light-emitting diodes. Together, these hardware features provide a user interface to monitor and control the ACR. 2 styles of operator interface provide different functionality depending on the user requirements. These 2 styles are the Set View interface and the Flex View interface. The Set View interface is a traditional OI that provides a 4x40 character LCD screen and simple navigation with 4 user-configurable quick keys. The FlexView operator interface provides the user with 20 indicator lights and 12 quick action keys, each with configurable lamps, which are totally configurable by the user through the WSOS5 operating system. This interface provides the user with instant feedback about the switchgear and minimizes the need to navigate through layers of menu structure. At the top of the ADVC processor, you can see the cables that could connect to communications, located in a cabinet space designed for that function. The diagram on the processor cover tells what type of connection is located directly above it. This is a close-up view of the battery, voltage supply, and main breakers. They should all be on while the unit is in operation. As you can see, the cubicle only requires 5 amps to function, even though the battery is capable of delivering up to 20 amps when fully charged. The AC supply is controlled by a duplex breaker. If the unit is running on the battery, check this breaker immediately and reset it. The gray cables are the connections from the ADVC control to the reclosers. The interface cables for the ADVC controller and its display unit are connected at this panel. If a special communication setup were required, it would be installed in this portion of the cabinet. You can see the gray communications cable connection here. This is an overview of an ADVC1 control, including a basic explanation of the control buttons and how to select different features. The main control can be reached by opening an access hatch on the front door. First, we have the red trip button, which will trip open the recloser. Above it, we have the green close button that will close in the unit if it has tripped out. Beside both the open and close buttons are the enable and disable switches. Ensure that these switches are set in the enable position. If they are turned to the disable position, the trip disable will not allow the unit to trip. The following descriptions outline the operation of the various elements in the SetView operator interface. Display: backlit LCD screen with 4 lines and 40 characters per line. Left scroll key selects the previous screen in a display group, or if a setting is selected, decreases its value. Select key. Press to select for a data field or setting so that it can be changed. Right scroll key. Select the next screen in a display group, or if a setting is selected, increase its value. Panel on key turns the operator interface on. The operator interface also will turn on when the cubicle door is opened. Trip key generates a trip request to the processor when the panel is active. A lamp is embedded in the key to indicate its operation. Another lamp is used to indicate whether the key's operation is disabled. Trip disable switch disables all trip operations. When the switch is in the disable position, the trip circuit in the switchgear is electrically disconnected from the control electronics. Thus, the switch provides a physical isolation point for the control circuitry. The switchgear cannot be opened, an audible alarm in the panel will sound, and the disabled LED in the trip key will flash. The trip key operates normally when the switch is in the enable position. This switch also prevents a close operation, so that the switchgear cannot be carrying load without the ability to trip. Close key generates a close request to the processor when the panel is active. A lamp is embedded in the key to indicate its operation. Another lamp is used to indicate whether this key's operation is disabled. Close disable switch disables all close operations. When the switch is in the disable position, the closed circuit in the switchgear is electrically disconnected from the control electronics. Thus, the switch provides a physical isolation point for the control circuitry. The switchgear cannot be closed, and an audible alarm in the panel will sound, and the disabled LED in the close key will flash. The close key operates normally when the switch is in the enable position. Custom menu key allows one access to the custom menu that was configured using WSOS 5. The custom menu is configured to provide a regular, updated data display by allowing a cycle of up to 12 screens. Alt key. The alternative function key gives access to an alternative event log display. Hotline tag lamp. When on, the lamp indicates that the hotline tag is set. Menu scroll key. Displays the first page of the next group. Pressing the menu key after changing a setting causes the setting change to take effect. Local/remote key. This is a configurable quick key with a default linkage to local/remote. Auto on/off key. This is a configurable quick key with a linkage set to hotline tag. Next, we will discuss the hotline tag function that is programmed to the quick action key labeled Auto On/Off. It is marked with an auxiliary white label to identify the custom programming of this key. To activate a hotline tag, press the Auto On/Off key once. You will see in the display screen the flashing words Work Tag Off. Press the button again and the display will flash the words Work Tag Applied. Press the Enter Quick Action key to activate the hotline tag. The red hotline tag LED will illuminate, indicating that the hotline tag is active. To remove the hotline tag, press the programmed Hotline Tag button, and the current status of hotline tag applied will appear on the display. Press the button again, and the display will read Hotline Tag Off. Finally, press the Enter button to activate the selection. The red hotline tag LED goes out to indicate the state of this feature. If you need to activate or deactivate ground protection, you would press the button once, and you would see a flashing EF on that stands for earth fault or ground. Press the button again, and the display reads EF off. Finally, press the Enter button, and the ground is turned off. To turn it back on, press the Ground Protection button once to see the status. Press again to change the status. And finally, press Enter to activate the change. The screen returns to its default view. The Custom Menu button has been programmed to provide information that you will require. Pressing the button will first take you to the Events log. You can scroll down through the log using the left arrow button, the latest event being at the top. The event log gives you the date and time, as well as the cause of the fault. To exit from the event log, press the Menu button a number of times until you reach the main menu. If you press the Custom Menu again, the Current screen appears. You can see any current flow that is actually going through the unit. If you're putting this recloser in or out of service, you would want to be viewing this display. If your leads are removed and the recloser is open, there will be no current flow. When you install your leads onto the actual unit with the bypass switch closed and the recloser open, you will still see zero current flow. If you reclose the unit with the bypass switch still closed, a percentage of current will go through the recloser and a percentage through the bypass switch. When you open the bypass switch, then each phase will be taking the full current through the recloser, and the amperages on the display will change accordingly. You will then know how much current is flowing through the unit. The local remote unit will enable you to communicate remotely. This function is presently not in use here. The Protection Group button would allow you to enable other protection settings, if it was so programmed. Flex View Operator Interface. This operator interface is more sophisticated than the set view operator interface in that the status of the device can be quickly ascertained via the set of colored LED lamps on the interface. The following descriptions outline the operation of the various elements in the FlexView operator interface. Display screen. This is a backlit LCD screen with 2 rows and 20 characters per row. Menu key. When a computer is unavailable, pressing Menu allows the user to enter the configuration menu from where it is possible to navigate the LCD menu structure, select fields, and edit settings. Arrow navigation keys. The arrow buttons are used to browse between display groups, fields, and change values. Select key. Select is used to select fields or values when changes are made. Panel on key turns the panel on or off. An optional door switch is available to turn the panel on when an operator opens the door and off when the door is closed. If the controller is fitted with this option, the button can be used to turn the panel off or on while the door is open. Closing the door turns the panel off. Lamp test key tests all lamps on the panel. The purpose is to alert the user of any lamps or colors that may not be working correctly. The test simultaneously cycles all lamps through red, orange, and green. Indicator lamps. These lamps are used to provide instant indication of the controller and switchgear status. Depending on the configuration, the lamps can be red, green, or orange, and on, off, or flashing. The multiple colors allow for grouping of similar functions. For example, red for protection, orange for voltage, and green for system health. Insert cards with the headings of the programmed functions are inserted into the A, B, and C banks so as to define the purpose of each LED. The configuration of the status lamps can be changed within WSOS version 5. Trip key trips the switchgear to lockout, and the green lamp located inside the button indicates the open state of the recloser. Lamp reset key resets the status lamps. Lamps requiring further attention from the operator remain lit. Note that some of the status lamps, such as controller power and terminal live, are continuously updated and therefore not affected by the reset command. Event log key displays the switchgear and controller event log on the LCD display. Older events can be viewed by pressing the up arrow key. Quick Action Unlock key. To use the quick action keys, an operator must first press the unlock key. The lamp above the unlock key will remain lit while the quick action keys are active. To deactivate the quick action keys, an operator can press the unlock key again. The lamp will turn off. Alternatively, the quick action keys will be deactivated automatically, with a short configurable delay after the last quick action key was selected. Quick action keys. Quick action keys allow the user to activate or deactivate functions directly from the interface without having to use the menu. The status condition of the function is indicated by the lamp next to the button. The lamp can be configured to be red, green, or orange in color and flashing. Before using the quick action keys, it is necessary to unlock the keys. Pressing a quick action key will apply that action without any further confirmation, and the lamp next to the key will indicate the new status. Enable or disable trip switch disables the trip key. When the switch is in the disable position, the trip coil in the recloser is electrically disconnected from the control electronics. Thus, the switch provides a physical isolation point for the control circuitry. The recloser cannot be opened, and an audible alarm in the panel will sound, and the disabled lamp in the trip key will flash. The trip key operates normally when the switch is in the enable position. Enable or disable close switch disables the close key. When the switch is in the disable position, the close coil in the recloser is electrically disconnected from the control electronics. Thus, the switch provides a physical isolation point for the control circuitry. The recloser cannot be closed, and an audible alarm in the panel will sound, and the disabled lamp in the close key will flash. The close key operates normally when the switch is in the enable position. ADVC2 status lamps. A brief explanation of the function and meaning of the various status lamp LEDs will help to clarify the understanding of the operator interface. In the first column, there are 6 LED status lamps. Lockout. Recloser has trip to lockout due to a protection sequence or operator command. Automatic close operations are not possible, and the operator has to close the recloser using the control panel or a remote command. The LED is red when activated. A, B, and/or C phase-over current. The most recent trip of the recloser was caused by an overcurrent event due to a fault on the relevant network phase or phases. These LEDs are red when activated. Ground fault. A ground fault has caused the recloser to trip. The LED is red when activated. Sensitive ground. The recloser has tripped due to a sensitive ground fault event. The LED is red when activated. In the second column, there are 6 LED status lamps, all of which are red when activated. Pickup. One of the protection elements detected a value outside the preferred range. For example, when the phase current exceeds the trip setting value. Reverse fault. Protection has operated in the reverse direction due to power flow from the load side to the source side of the recloser. OU frequency indicates that an over or under frequency event has caused the recloser to trip. OU voltage indicates that an over or under voltage event has caused the recloser to trip. External trip. An external device has instructed the controller to trip the switchgear. Operator indicates that a local or remote operator has tripped the recloser. The third bank of status LEDs provides information regarding the switchgear and control status, as well as the overhead voltage status. A, B, and C phase live. The source or load side bushing of the relevant phase is live. These 3 LEDs are orange in color when active. Load current on. This LED is red when a load current of more than 2 amperes is flowing through the switchgear. System OK. The controller is functioning normally when the lamp is green. Maintenance may be required when the lamp is flashing red. Consult the event log. AC power. This LED is green when the AC source is OK and flashes red when it is not. Battery. This LED is normally green if the battery is on and in good condition. It will flash red if the battery is off or if it has failed a battery self-test routine. Alarm. This is a flashing red lamp when the trip or close circuits are isolated, the contact life is low, or the switchgear is locked. The quick action buttons or keys. A group of 9 quick action buttons, alternately called keys, allow the operator to select functions directly from the panel. Selecting a quick action button or key will apply that action without any additional confirmation, and the lamp next to the key will indicate when the action is active. Before selecting a quick action, the operator must first unlock the quick action buttons. This is done by pressing the Unlock button. It is possible to press a sequence of quick action buttons while the unlock lamp is lit. The buttons will be locked automatically after a short delay once the last key is pressed, or alternatively, when the unlock button is pressed a second time. This controller is programmed with a default quick action button configuration that provides access to frequently used actions. We will briefly elaborate on the functions of each of the quick action keys. Live load blocking. The key toggles the live load blocking feature on or off. A red lamp indicator shows when the function is on. Live load blocking prevents a recloser from closing if any of the load side terminals are live. The live load threshold voltage range is from 2 to 15 kilovolts. Loop automation. Turns the loop automation feature on or off. A red lamp indicator shows when the function is on. Battery test. This button performs a battery test, and the result is displayed in the event log. A red lamp indicator shows when the function is on. Group protection A, B, or C. These three keys activate the settings configured in protection group A, B, or C one at a time. The user can quickly access any of the pre-programmed setups. A red lamp indicator shows when the function is on. Auto ACR LBS. The key toggles the Auto Reclose for reclosers or the Sectionalize Auto feature for sectionalizers on or off. A red lamp indicator shows when Auto is on. Ground fault. Turns ground fault protection on or off. A red lamp indicator shows when the function is on. Sensitive ground. Turns sensitive earth or ground fault protection on or off. Remote control. The key turns remote control on and local control off. A red lamp indicator shows when the controller is in the remote mode. Local control. The key turns local control on and remote control off. A red lamp indicator shows when the controller is in local mode. Hotline tag, or work tag, is applied using this key. Work tagging ensures that closing cannot take place and also activates the work tag protection settings. To activate or deactivate any of these keys, you must first press the lock button. The green indicator will reset to a red lock state if no selection is made within a 20-second window. To activate live load blocking, first press the lock button, followed by the live load blocking button. This will detect any voltages on the load side of the recloser. If voltage is present, it would not be allowed to be closed. This is typically not used. In order to close the recloser, you must turn off the live load block feature. Remote control and local control. When controlling this unit from the actual recloser control, you will be under local control. Press the lock button followed by the remote control button when tied to a communication system where the OGCC is monitoring and operating this control. This will deactivate the local control. In this state, the control will not respond locally. The only button that will respond in this state is the trip button. To remove remote control and return to local control, Event log. After pushing this button, the arrow buttons will allow you to scroll through the most recent operations. The display here indicates mechanism fail. This is because a recloser is not present. Scrolling menu display. To access the current display from the main default display, press the down arrow to reach Operation menu. Press Select. Scroll down to reach Measurements. Press Select. This will display System Measurements. Scroll down again to display Current. Press Select. You are now able to scroll through A phase current, B phase current, C phase current, and ground or neutral. Press Menu to return to the main display screen. Trip and close. If this recloser were tripped open, there would be a lockout indication above. The LED here on the trip button will also illuminate. The trip disabled indicator will illuminate after pressing the Disable Trip Circuit button below. To reactivate, press the Enable Trip Circuit button. The disabled indicator will now turn off. You may now trip the unit. Close button. If the recloser is closed, the LED in the top left corner will illuminate. Below is the disabled indicator. To disable the close feature, press the Disable Close Circuit button. This unit is now unable to close. In order to close this unit, press the Enable Close Circuit button below. The disabled indicator here will turn off. You can now close the unit. On the bottom of the unit, below a plastic flap, are 3 supply breakers. The first breaker on the left-hand side is the AC supply breaker. If the AC power has been turned off on the above display, check your breaker. It should be in the down position. To test this, switch it to the up position. If it remains steady and the AC power light returns to its normal state, you have verified that the unit is up and running. The middle set of breakers supplies a utility outlet, which is located on the left side of the control. This is used for powering equipment such as laptops. The final breaker supplies DC to the control. This is tied into the batteries on the bottom of the control panel. It has a battery backup that lasts for approximately 36 hours. The ADVC cold load pickup function. When a typical heterogeneous load has been without supply for a period of time, as in hours, it loses its diversity. After supply is restored, the load is higher than before the loss of supply because all heater, refrigerator, or air conditioner thermostats have turned on. The longer the time without supply, the greater the loss of diversity. Therefore, the higher the load current after supply is restored. This increase in load current may cause overcurrent protection elements to operate. The purpose of the cold load pickup feature is to compensate for the loss of diversity automatically, so the increased load will not cause overcurrent protection to operate. It works by measuring the time that supply is lost, and then temporarily raising the trip current for a time according to the time supply was lost. The increase in trip current is determined by the cold load multiplier that is set by the user. The user specifies a multiplier and a time. The ADVC detects when load current is 0 and starts a timer called the operational cold load time. Using this timer, an operational cold load multiplier is calculated. The phase and earth protection thresholds will increase at a rate specified by Hydro 1 when the load is turned off, but only up to the user set cold load multiplier factor. The ADVC calculates the new thresholds every minute. For example, if the user set cold load time is 2 hours, the user set cold load multiplier is times 2, and the current has been off for 1 hour, then the operational cold load time is 1 hour. Consequently, the phase and earth thresholds are increased to equal the operational cold load multiplier of 1.5. Once load current is restored, the operational cold load timer starts to count down. This means that the operational cold load multiplier returns to 1 in 1 hour, and hence the phase and earth threshold currents also return to their normal values. In this way, lost load diversity is automatically compensated for. It doesn't matter where the current was turned off, for example at the substation or at the recloser. The compensation will still work. Following is a basic overview of the Cooper FXB recloser control, which mates up with the Cooper WVE38 recloser. Let's start with the fault targets on the left side of the panel. Bushings 1 and 2 will be your source load, closest to the operating handle. Bushings 3 and 4 will be the center bushings, and bushings 5 and 6 will be the farthest away from the operating handle. The ground LED indicator will tell you if you've had a ground fault. All of these bushings will activate under phase fault conditions, identifying which phase has faulted. The sensitive earth SGF-SEF function is not active in this control, therefore the indicator will stay off. When active, this indicator will become red. Moving down to the next group, we have the status indicators. The first is recloser closed, followed by recloser open. As you can see now, the recloser is open, as indicated by a green LED. A green LED also indicates a control lockout. If the control has gone to a lockout state and all contacts are open, this light will be on. Control OK. This unit performs self-diagnostics. If the control is functioning properly, this LED will be red at all times. Current above minimum trip will only be illuminated during the time that the unit is in a trip condition. Ground trip blocked. If one were to set the ground and block it to prevent it from activating on ground, this LED would be illuminated. Non-reclosing active will activate when you push the non-reclosing button or when you set a hotline tag, your hold-off feature. Alternate minimum trip. There are 3 settings groups available in this control. If you were to push the alternate minimum trip setting button, this LED would be illuminated. Finally, sensitive earth blocked or SGF-SEF is illuminated with an amber light. Since this is not activated in any of our controls, this light will remain on. Next, let's take a look at the ground trip blocked button. If you are performing switching procedures or taking this recloser in and out of service, it is recommended that you push the ground trip blocked button. To turn this off and to make the ground setting active again, press the button one time. If there were a second set of group settings programmed, you would push the alternate minimum trip button. The LED would turn red. You will also see an amber light here on the side, indicating that the second or alternate trip setting is active. These are always programmed at present state with the same settings. To turn it back off, simply press the button. Pressing the non-reclosing button will cause its LED to turn red and the non-reclosing active LED on the left side to turn amber. Regardless of its current state, there will be only one shot until lockout. Pressing it again will return to the normal multi-shot reclose. The recommended way of applying a hotline tag is by switching the hotline tag switch on. You will notice the hotline tag LED, the non-reclosing LED, and the non-reclosing active LED all become illuminated. Throwing this switch eliminates any possibility of this control being activated by means other than this switch. If the supervisory LED was on, and this was connected to a SCADA system or a remote, an override would not be possible. The hotline tag must be installed or removed by personnel in the field. To remove the hotline tag, move the switch down, and all of the indicator LEDs will return to their normal state. Along the bottom of the unit, we have the green trip and the red close buttons. After pushing the close button, you will notice the status indicator LED for recloser closed change state. The recloser is now closed. To trip, simply press the trip button, causing the recloser to trip open. The green recloser open and control lockout LEDs on the left side will illuminate. When you open the enclosure, you will see the word Configuration on the green display screen. The selection buttons across the bottom will allow you to access the system and perform various control checks. After selecting Counter Operations, you will notice the screen displays that this particular unit has gone through 237 operations. Pressing Escape will return to the main menu screen. Pressing RMS Current will display the current that is flowing through the recloser. If your source and load side leads are installed and the reclosers are open, you should have no current supply going through it. With the bypass switch still closed, press the Close button to close the recloser. You will notice on the display that a percentage of the amperage is now going through the recloser, as well as a percentage through the bypass switch. The display now shows verification that we have amperage on all 3 phases. It is now safe to open the bypass switch. Approximately 1/4 to 1/3 of the amperage should flow through the recloser. Now, press Escape to return to the main menu. Pressing the Battery Test button will perform a self-check on the battery. The screen now displays the unloaded state, which is the present voltage of the battery. It also displays the loaded state, which verifies that the battery is in working order. Reset targets. If you have any targets that have activated, when you close the control in, those targets will reset. If you wish to reset them manually, pressing the Reset Targets will return all of the indicators to their normal state. Across the top of the control are more selection items. From left to right are the up and down selection buttons and the Edit button, used to change control settings. Next is the Enter button, which allows you to access whatever features are currently available on the display, followed by the Escape button, which allows you to return to the main menu. After pressing the Enter button, you can scroll through selections using the arrow keys, such as Control, Recloser, Communications, and Password. Let's scroll back up to Control and press Enter. The screen will now display the type of control, the firmware version, and the control date and time that are currently programmed. Now, pressing the down arrow will display Device ID, Control Firmware, and Control Database Release versions. Now, press Escape to return to Control. Press the down arrow and then Enter. The screen will now display line frequency, CT ratio, and interrupter duty. This latter number is a calculation that will tell you the percentage of wear on your contacts. The control does this calculation for you. Press Escape. Use the down arrow to select Communications and press Enter. This will display an address and baud rate, which is only used for communicating remotely to this unit. From the configuration screen, use the arrow key to scroll down to Basic Settings. That will display the settings for this recloser. Scroll down again to view Advanced Parameters, Metering and Counters, and finally, Event Recorder, which is very useful to determine what caused the unit to trip. While on the Event Recorder screen, press the Enter button. The first event displayed here is Event 1, which was the last performed operation by this unit. Pressing Enter again will show an explanation of exactly what happened. As seen earlier, this unit was demonstrating opening and closing the recloser. The final event, Event 1, is shown here as Close via Control. The date and time of this event are also displayed below. Were this a phase fault or ground fault, the phase or phases would be displayed along with the appropriate date and time. Scrolling down from this point will display the phase and ground. Use the Escape key to back out and find an event. Using the down arrow to drop down to Event 20, press Enter. The screen will now display the event, in this case a trip from phase to ground. The date and time are also displayed. Press down again to display the amperage on each phase, along with the actual faulted phase. In this application, the display shows that the phase 3 to 4 center bushing tripped out at 382 amps. These units are set to trip at 350 amps. Pressing Escape 3 times will return you to the main display screen. On the bottom of the unit are the battery test terminals. Applying a voltmeter to these will display the current floating voltage state of the battery. Across the top of the control cabinet are fuses. These fuses are for the control panel, the receptacle inside the control panel, along with the 240-volt supply for the closing coil. Should a problem occur with this unit, such as a lack of AC power or a recloser refusing to close, please verify that from the fuse to the ground that you have got 120 volts. A closer look at the left-hand side of the control cabinet, you will see the fault target indicators. These are labeled as bushings 1 to 2, 3 to 4, 5 to 6, ground, and sensitive earth or SGF-SEF. The latter will not display as that feature is turned off. All other indicators will activate whenever a fault occurs on your A, B, C, or red, white, and blue phases. Ground will also activate whenever an earth fault occurs. Down the left side of the control panel, below the fault targets, you will see indications as to the recloser's status. Starting from the top is recloser closed, which is now red, indicating that it is now closed. Next is recloser open, which will light up green if the recloser is open. Control lockout will illuminate red if the control has been tripped open manually or gone to a lockout state. Below that is Control OK, which is a self-check that tells you that the control is OK. While there is a fault being applied, the current above minimum trip LED will illuminate. Ground trip blocked will illuminate when the ground trip button is applied. This is used to tell you that the ground is blocked. Next is non-reclosing active. This indicates that the recloser will not reclose after an operation. This is identical to a hold-off or hotline tag. Alternate minimum settings is a second settings group in the control that can be activated by pushing the alternate minimum trip button. The light will turn amber. On the bottom is an SGF-SEF sensitive earth fault. This is currently blocked or turned off within the control, and so it illuminates amber. Looking more closely in the center of the control, you will notice 3 reference buttons, in addition to the hotline tag switch. These are selection features. On the top left-hand side is the ground trip blocked button. By pressing this button, you will block your ground. Below that you will see the alternate minimum trip button. This will apply a second set of settings into the control and make them active. You will notice this LED illuminate in addition to the status LED on the side. Applying the non-reclosing button will not allow the recloser to reclose. It is basically the same as a hold-off or hotline tag. If the hotline tag switch is applied, the unit goes into a non-reclosing state and also does not allow any supervisory or remote communications to change the state. In-field personnel must physically apply and remove the hotline tag. Looking more closely on the bottom of the unit are the green trip and red close buttons. Since this is a gang-operated unit, applying the trip button will actively trip out all 3 phases. The phase indicator LED will signal a status change. After pressing the close button, you will notice that all 3 phases have closed, as indicated by the recloser closed LED on the left side of the panel. After pressing the trip button, you will notice the recloser open and control lockout indicators are now green. Pressing the close button will close all 3 phases, causing the recloser closed indicator to turn red. Looking more closely across the bottom of the unit are the battery test terminals. A load test or voltage test may be applied to these terminals to determine the current idle voltage of the batteries. This is achieved by applying a voltmeter between these 2 terminals. Looking more closely at the display screen, we see that the opening screen is set to Configuration. Using the operations buttons below will identify certain conditions. For example, pressing Operations Counter will display the total number of operations performed by the unit. Pressing Escape would return you to the main display screen. Press the RMS Current button to display the current presently flowing through the recloser. Press Escape to return to the main display screen. To ensure that all LEDs are in working order, press the Display Test button. LCD User Interface. The FXB Control LCD User Interface consists of the following elements: a row of 5 manual operation buttons or keys located below the 4-line by 20-character LCD display that are used to navigate through the menu system and to view or edit control parameters. These keys are Up, Down, Edit, Enter, and Escape. A text-based 4-line by 20-character LCD display located above the first row of 5 manual operation buttons or keys. A second row of 5 operation buttons or hotkeys that are used to perform specific functions. These hotkeys are Operation Counter, RMS Current, Display Test, Battery Test, and Reset Targets. Menu System. The LCD menu system consists of the following levels: Level 1 Main Menu Items, Level 2 Submenu, which contains items within each main menu item, Level 3 Page Menu, which may contain up to 4 parameters within each submenu item. Where possible, menus and parameters have been grouped to follow the arrangement of the Cooper Power System Keil Distribution Switchgear FX, FXA, and FXB programmer software, using manual operation switches. The use of manual operation switches provides designated control commands to the recloser. The switches also provide an alternative to using a computer interface or scrolling through the LCD menus. Supervisory On. The Supervisory On feature is provided on controls equipped with the optional SCADA accessory. If the Supervisory On switch is on, it allows supervisory operation of the control. Conversely, if the Supervisory On switch is not on, it prevents supervisory operation of the control. Hotline Tag. Hotline Tag prevents all closing operations by opening control contacts in series with the recloser low-voltage closing circuit coil. If the feature is activated while the recloser is closed and the control is in the reset or home position, a fault will cause one trip operation to lock out. Ground Trip Blocked. Ground fault trip operation of the control is disabled when the ground trip block switch is set in the block position. Blocking ground trip operations is useful during known periods of 3-phase load imbalance and is recommended while performing single-phase load imbalance, testing, or switching. Non-reclosing. By setting the operating mode switch to non-reclosing, the FXB control will block reclosing after an automatic trip, one trip operation to lockout, on TCC number 1 for phase and ground. When set in the normal reclosing mode, the FXB control will operate on its programmed operating sequence. Alternate minimum trip. This switch permits switching to alternate pre-programmed phase, ground, and sensitive ground fault minimum trip values. Trip or lockout and close switches. Pressing the green trip switch opens the recloser, and the control locks out. Pressing the red close button returns the recloser to the reset condition, and the recloser closes. While the switch is in the close position, the control is still free to trip and lock out if closed into a fault. The first version of electronics used in controllers were the Form 3A. The Keil Type ME Form 3 or 3A electronic recloser control are comprised of a number of programmable, solid-state electronic circuits that perform the command functions involved in automatic recloser operation. It is used to operate all Keil electronically controlled reclosers. The upper black portion of the front panel contains the plug-in components and setting knobs for programming automatic recloser operation. The switches and indicators used for manual operation and service are grouped on the bottom light portion of the panel. The front panel is backed by a printed circuit tie board that supports and interfaces the plug-in circuit boards with other related circuit components. Program-altering, remote control, indicating, and general convenience accessories can be added to further expand and enhance the application capabilities of the control. Line current flowing through the recloser is sensed by 3 internally mounted bushing current transformers, one on each phase. When the phase current or the zero sequence ground current exceeds its programmed minimum trip value, the electronic control initiates the programmed sequence of recloser tripping and reclosing operations. If the fault is temporary, the control ceases to command recloser operations after successful reclose, and the control resets to the start of its operating sequence after a preset time delay. If the fault is permanent, the control performs its complete programmed sequence of recloser commands and locks out with the recloser open. Once locked out, the control must be manually reset to the start of its operating sequence that simultaneously closes the recloser. Factory-calibrated timing plugs establish the time current characteristics for both phase and ground tripping. 2 sets of individual timing curves provide dual timing for both phase and ground. Operation. Factory-calibrated timing plugs establish the time current characteristics for both phase and ground tripping. 2 sets of individual timing curves provide dual timing for both phase and ground. The line current conditions are continuously monitored by the 3 bushing-type current transformers in the recloser. Output from these transformers is fed to the trip network in the control, which includes the minimum trip resistors, isolation transformers, and rectifier circuits. If current remains above the minimum trip level, the tripping reclosing sequence of fast and delayed operations is repeated as programmed to lockout. When current above the selected minimum trip level is detected in 1 or more phases, the following chain of events will occur for an operating sequence of 2 fast and 2 delayed operations. The overcurrent signal is integrated with time on the characteristic curve of the timing plug to produce the signal which energizes the trip circuit. Energizing the trip circuit connects the battery to the trip solenoid, tripping the recloser. Simultaneously, the sequence relay advances to energize the first reclosing interval delay plug. Upon expiration of this reclosing interval delay, a closing signal from the control closes the recloser, and the sequence relay sets up the circuitry for the second fast trip operation. If the overcurrent is cleared before the operating sequence reaches lockout, the reset delay circuit starts timing when the recloser closes into the unfaltered line. When the reset delay plug times out, the sequence relay is reset to the start or home position, and the control is ready for another 2 fast, 2 delayed trip operating sequence. However, should the fault restart before the reset plug times out, the control will continue its operating sequence where it left off last, and the reset delay timing will be erased. Ground fault sensing and tripping operations occur exactly the same as phase fault sensing and tripping, except that zero sequence ground current is sensed instead of phase current. The ground fault circuitry includes its own minimum trip resistor, fast and delayed trip timing plugs, and number of fast operations setting. Reclose and reset intervals and operations to lock out are common for both phase trip and ground trip modes of operation. There is a handle to open and close the recloser. Turn clockwise to close, counterclockwise to open. The indicator above the handle is red for closed, green for open. If the recloser trips, the indicator will turn green. Below these, we have the target indicators. This has status indicators for ground, A phase, B phase, and C phase. Upon tripping this recloser and when set for auto reset, these will display while tripping. Upon lockout, this setup will remain. By moving the toggle switch to manual reset, you can reset these targets. This will be a basic overview of one of the first types of electronic controllers. This is an electromechanical Cooper Form 3A control, used in conjunction with a Cooper WVE38 recloser. The unit has separate trip coils. It also has separate ground and phase resistors. It also has a separate ground, and phase resistors are used on this unit to provide the trip amperages. These were the very first type of electronic controls. Across the top of the unit are the operation selectors for the ground trip socket, the lockout socket, and the phase trip socket. The phase trip socket 1 will be set to your fast operation. In this particular unit, the selector is set to 0. The ground trip socket 1 selector is used to select the number of fast ground trip operations as defined by the timing plug in socket 1. The remaining slower operations are defined by the plug in ground trip socket 2. On this unit, it is set to 0. The center rotary knob is used to set the total number of operations to lockout. This unit is set for 3. Phase Fast Trip programs the number of fast phase trip operations as defined by the plug in socket 1. The remaining slower operations are defined by the plug in the phase trip socket 2. The unit is set to 0. Reclosing interface delays. When the recloser opens, there will be a dead time before it recloses. All 3 of these are set for 2 seconds of open time. Below these, we have the target indicators. This has status indicators for ground, A phase, B phase, and C phase. Upon tripping this recloser and when set for auto reset, these will display while tripping. Upon lockout, this setup will remain. By moving the toggle switch to manual reset, you can reset these targets. Next are the 3 phases and ground trip yellow-colored resistors. Each one of these has a threshold trip value, in this case a 400 amp ground setting and 600 amp phase setting. The 600 amp trip settings for each phase are a gang-operated unit and cannot be operated individually. All 3 phases will trip when requested by the control. On the right side of the unit are silver-colored plugs, which provide a number of alternative timing curves for your ground and phase trip functions. For the first ground trip socket, this is your fast curve, a number 1 trip coil curve. The second socket is for the slow curve, and the plug is a number 14. For the phase trip timing, the third or fast plug is an A for the number 1 curve, and the fourth silver plug is the slow or number 2 curve, and is a D plug. Across the bottom is an adjustable reset delay. Upon closing the control, you will have 10 seconds before the control will revert back to its first operation. On the bottom is a silver toggle switch for the ground trip blocked function. This is used for testing or switching requirements. Below that switch is another silver toggle switch for the non-reclosing function. This would be your hold-off switch. By switching this up to the non-reclose position, you will have a hotline tag. Switching it back down will enable normal reclosing. In the center of the unit is the black trip and close handle. Close by turning this fully to the right with the pointer on close. Turn to the left with the pointer on trip to open, and the indicator will turn green. The phase and ground doubler silver toggle switch increases the threshold on these for a cold load pickup state. Next is the lamp test. Switching this 3-position toggle switch to the up position will test functionality of the lamps. Moving the toggle to the down position will perform a lockout test, but be aware that this might trip a lockout. There is also a quick trip button used for test purposes. Next are battery terminals. These can be used to test functionality of the batteries. The reclosers cannot be operated by the control panel in the automatic mode. If the battery falls below a certain threshold level, it will have to be opened manually. This is the DC milliamperes display. This shows that the battery is in a charged state. This indicates whether or not the charger is working. When performing testing procedures, you'll notice a drain on the battery. If this remains on, your battery is beginning to deplete. The DC milliamperes display is for evaluation of your battery and charger. In a test position, you'll notice a certain draw on your battery. This will raise the milliamps deflection. When the batteries are fully charged and in good condition, you'll see a minimal trickle charge applied. While under normal operating conditions, if you notice the display is above a trickle charge, your batteries are beginning to wear out and require replacement. If you find yourself in the situation where the close handle within the control does not function and the manual operating handle for the recloser is in the up position, you need to check the condition of the slow-blowing closing coil fuse. Typically, there are spare fuses in the bottom of the enclosure. The Keil Form 6 rack-mount microprocessor-based recloser control includes extensive system protection functionality, including phase, ground, and negative sequence overcurrent protection, over-under frequency, and voltage protection, directionality, sensitive ground fault, and sync check. Metering functions include demand and instantaneous current on a per-phase basis, instantaneous voltage and power factor on a per-phase basis, and power, real, reactive, apparent. The front panel LCD display is used to configure the operating settings for the control. It is also used to display metering, counter information, control parameters, reset alarms, and provide diagnostic information. Control parameters can also be programmed via a personal computer connected to the control through the front panel RS-232 port. Control programming, interrogation, and operations are performed with Form 6 ProView interface software on a personal computer. The interface program software includes additional functions used to create and graphically display time current curves and provide IDEA workbench for configuring user-selected inputs and outputs, configurable event and alarm data, and selectable communication points for serial communication. The control operates on 50 and 60 Hz systems. The control can be configured by the factory or by the user for a wide variety of applications. If user requirements change, the control functions can be modified to meet the new requirements. Theory of operation. Current sensing is provided by 3 current transformers located in the recloser and interface to the Form 6 recloser control via control wiring. This wiring also supplies trip, close, and recloser status and connects to the recloser interface or RIF module to provide isolation for reliable operation. A functional block diagram of the Form 6 recloser control is shown. Line current flowing through the recloser is converted by the CPU module to a digital signal suitable for metering and fault current calculations. Data sampling occurs at a rate of 64 times per cycle. The CPU contains a data acquisition section that uses the acquired samples to compute the fundamental currents and voltage for use in overcurrent, under-over-voltage, and under-over-frequency protection, as well as currents and voltages for metering functions. The current for overcurrent protection is calculated on a sub-cycle basis. It includes only the fundamental and DC component. Protection profiles. 4 protection profiles capable of fully specifying control operation are standard in the control. Each protection profile includes the following as a minimum: overcurrent protection, over-under voltage protection, over-under frequency protection, directional protection, hotline tag functionality, sync check, sensitive earth fault protection, sequence coordination, and operation settings. When the phase or ground current exceeds its programmed minimum trip value and associated time current curve or TCC timing, the control initiates the programmed sequence of recloser tripping and reclosing operations via the CPU and RIF modules. If the fault is temporary, the control resets to the start of its operating sequence after a preset time delay. If the fault is permanent, the control performs its complete programmed sequence of reclose commands and locks out with the recloser open. Once locked out, the control must be closed via the operator panel or SCADA communications. This resets the control to the start of the operating sequence. Hotline tag is provided for live line work applications. All closing operations are disabled when the hotline tag feature is activated. While active, the control utilizes an independent, user-selectable time current curve for trip operations. Important: hotline tag activation does not cause the recloser to trip open. It only prevents the recloser from closing. Important: hotline tag is intended solely for live line work applications, such as maintenance, repairs, or improvements to the distribution system that occur while the line remains energized. Hotline tag prevents all closing attempts and shifts protection to one trip to lockout on the composite curve of the hotline tag definite time and the TCC1 curve, whichever is faster. Hotline tag takes precedence over cold load pickup, non-reclosing, and fast trips disabled. Hotline tag is activated from either the operator panel toggle switch, serial communications, or a discrete SCADA function. All sources must be off to deactivate hotline tag. To activate the function from the operator panel, flip the toggle switch up to the on position. The LED indicator illuminates when the function is active. The hotline tag function may only be reset by the source which initiates it. For example, if hotline tag is activated at the operator panel, the reset function is only possible at the operator panel and not via SCADA command. Closed circuit disable is a removable fuse that, when removed from the front operating panel, disables the closed circuit from the control to the recloser. Removing the cartridge from the control disables all electrical closing of the recloser and provides a physical disconnect to the recloser closing circuit. As a result, the control cannot perform a close operation. The disconnect overrides all close functions and makes a remote or manual close operation impossible. Note: when the closed circuit disable fuse is removed, the trip circuit remains active and will trip per the programmed time current curve for a faulted condition. Important: if the close button is pressed after the closed circuit disable fuse is removed, do not reinstall the fuse until after the alarm LED illuminates within approximately 5 seconds to indicate close malfunction. Reinstalling the closed circuit disable fuse prior to the close malfunction alarm indication will cause the control to close the recloser. Trip Lockout Push Button. The Trip Push Button provides front panel access to trip or lock out the recloser. When pressed, the Trip Push Button opens the recloser and locks out the control. The Trip Push Button operates independent of the microprocessor and is directly connected to the trip coil in the recloser. Note: in the event of microprocessor failure, the trip circuit will remain active. Close Push Button. When pressed, the Close Push Button returns the control to the initial or home position, closing the recloser. The control is ready for the start of a new trip close sequence. The ground trip blocked function blocks all ground sensing in the control for the active profile. This red indicator is illuminated when ground trip block is activated from the serial port, input-output, the interface software, or locally causing the control to block all ground sensing. Non-reclosing. The control is operating in a non-reclosing mode when the non-reclosing red indicator is illuminated. Non-reclosing mode disables any automatic reclosing operations. Non-reclosing does not alter the active TCC. Activation is possible from the serial port, input-output, the interface software, or locally. High current lockout. The high current lockout feature will automatically lock out the control on the selected operation when current exceeds a programmable level. The active trip numbers for the lockout is selectable for phase, ground, and negative sequence. This feature is independently selectable for each protection profile. Sensitive ground earth fault operation. The control has a sensitive ground earth fault trip feature that provides tripping of the recloser after a programmable definite time for ground currents below normal ground minimum trip levels. The feature has programmable operations to lock out and reclose intervals independent of the ground settings. This feature is independently selectable for each protection profile. Metering. The control provides instantaneous and/or demand metering with programmable integration intervals for the following functions: real and reactive power for each phase and total, including directional, on an individual phase basis. Demand currents on a per-phase basis. Instantaneous currents, including ground current. Instantaneous voltage on a per-phase basis. Instantaneous frequency. Positive, negative, and zero sequence voltages. Instantaneous power factor on a per-phase basis. Metering settings to include demand interval and alarm thresholds for current, single-phase kilowatt, three-phase kilowatt, single-phase kVAR, and three-phase kVAR. Fault location. The control includes an impedance-based fault locator based upon the Takagi algorithm. Load-compensated impedance calculation is used for calculating the distance. Positive and zero sequence is configured in ohms, and the fault locator line length is configured in kilometers/miles. This is the Cooper Form 6 control. It will be interfaced with a WVE recloser. Let's take a look at the top row of indicators. If the AC supply is active and the control has performed a self-diagnostic, the control on and control power indicators will both be green. Should the control go to a lockout state after a trip, the control lockout indicator will turn red. The recloser will be open at this point, causing the recloser open indicator to also turn red. The recloser closed indicator will turn red when the recloser is in a closed position. Next, we have the phase fault indicators: A phase fault, B phase fault, C phase fault, ground fault, and sensitive ground fault. These will illuminate to identify which phase caused the lockout trip. Sensitive ground fault is currently not used in the programming of these controls. Alarm. This will illuminate and flash should a control or recloser malfunction occur. The minimum trip indicator will illuminate if the current rises above the minimum trip. This will occur while the trip is in process. The indicators 1, 2, and 3 are currently not used in this process. In the next column, we have phase voltage A, phase voltage B, and phase voltage C. If the control were supplied with external PTs, these would illuminate red as a phase voltage must be present. These are currently not in use. Frequency trip. If this unit was programmed for frequency and it lost frequency lock, then the light would turn on. Voltage trip. If the program were set for voltage operation and the voltage dropped below or elevated above a certain threshold, this light will turn red. This unit is typically not used. The final set of indicators on the right are programmable LEDs that can be used for other functions. These are presently not being used. Push buttons are used to access different features on the display screen. Metering. Pressing this button will display the A, B, C, and ground current. If voltage were applied, you would also see A, B, C voltages. Target reset. If the control trips out under a faulted condition and you wish to reset the targets before closing, press this button. Pressing this button will clear all unused items. Events. By pressing the Events button followed by the Enter button, the most recent trip will be displayed. Using the arrow keys, you can now scroll through subsequent trips, up to 40 operations. The display screen shows a manual trip to lockout. No currents are displayed. Press the Menu button to back out of this selection and return to the main menu. Lamp Test. This is used to test LED functionality. Again, press Menu to return to the main menu. Settings. Press this button followed by the Enter button. After typing in your password, Settings will be displayed. Typically, this is only accessed by protection and control staff. Press Menu to return to the main menu. Operating Counter. Pressing this button will display which phases have been tripped. At the top of the display is a trip counter. This currently reads 7. A phase and B phase both display 0. Scroll down to find the C phase. This will indicate how many operations each contact has performed on a faulted condition. Press the Menu button to return to the main menu. Alarms. Press the Alarm button if the alarm indicator is flashing. The screen will now display the active alarms. After identifying the alarm, press the Reset button. Reset would come across these 4 bottom buttons: F1, F2, F3, and F4. Change. This button is utilized for changing settings in the control or to change any of these features located at the bottom. Ground trip blocked. To block your ground, press the Change button, followed by the Ground trip blocked button. Repeat this process to remove this condition. Non-reclosing. Press the Change button, followed by the Non-reclosing button. This will give you one shot until lockout. This is not a hotline tag. Pressing the Close button can still close the control. This is strictly for testing purposes. Press the Change and Non-reclosing button again to turn this feature off. If this unit is connected to OGCC communications, supervisory functioning would be provided. If supervisory is not connected, press the Change button followed by Supervisory Off. These reclosures are normally not connected to the OGCC. There are 3 sets of alternate programs. If these were programmed, they could be activated by pressing the Change button and then selecting the active profile. There would be new settings in the control. To return to the normal control settings, press the Change button. This will remove the alternate settings. The final set of buttons on the bottom of the control, Option 1, 2, and 3, are programmable for advanced functions. These are presently not used. Trip and Close buttons. To trip the unit, press the Trip button. Lockout will be displayed on the indicator. Press the Close button to close. The recloser closed indicator will light up. Hotline tag, hold off. This is a toggle switch in the center of the control. Flipping this switch in the up position will activate the hotline tag as indicated by the LEDs. This will give you one fast operation until lockout. Under this condition, you cannot close the unit back in if it trips out. You must first remove the hotline tag. If you wish to disable the close circuit, there is a fuse that can be removed. This is typically only used for testing procedures. Pickup will indicate a phase pickup or ground pickup. Lockout will indicate a lockout condition. Phase OC will indicate a phase overcurrent. Ground OC will indicate a ground overcurrent. User 1 and 2 are only used when connected to the actual control. Self-check. To verify that the control is functioning properly, Every hour or after pressing the Enter button, this unit will perform a self-check diagnostic. A green LED will indicate the unit is functioning properly. Battery test. Pressing this button will perform a battery test. The indicator will turn red. The pass and verified delta voltage will be displayed. The directional arrows will allow you to scroll through selections on the screen. Pressing the Enter button once will display meter. Now, scrolling the down arrow, we can scroll to Meter, Settings, and Records. Now, pressing Enter will display the fault summary. Pressing down from here will display Fault Record. Now press Enter to display the number of faults recorded. The left and right arrows will now scroll through the desired fault record. Pressing the Clear button will back out through the previous selections until returning you to the main menu screen. The directional arrows will only become active after making a selection with the Enter button. And now for a brief overview of what to look for should this unit have tripped out. The Open indicator would show green beside the Open push button. At the top, you would see a red lockout indicator LED. There would also be an LED status indication beside the phase or ground overcurrent, depending on the nature of the fault. The next visible indicators will be up on the actual recloser. There are individual indicators across the bottom of the recloser. These are red when closed and green when open. If it is set for a single-phase trip, you could have 1, 2, or all 3 open. If it is set for gang operation, all 3 will open and turn green. Inside the back panel, you will see the interface on the control for connecting wet and dry contacts, a trip capacitor, and batteries and fuses along the edge, which are for the control and/or separate individual PT inputs if required. There is typically no need for a lineman to open the swing door on the control panel. This is a brief operational overview of the ABB PCD 2000 electronic control, starting with the top LED status indicators at the top of the control. Pickup. This displays when the recloser has picked up on a fault. Lockout. This LED will turn red when the recloser has tripped to lockout. Phase overcurrent. This LED will turn red upon a phase overcurrent trip. Ground overcurrent. This will turn red upon a ground overcurrent trip. User 1 and 2 are only used when you are connected to the control. The default display screen will show the actual current flow through each individual phase, A, B, and C, in addition to the IN, which is your calculated imbalance or neutral. Moving down along the left side of the unit, we have Remote Blocked. This is only active when communications are linked to the unit. To block communications, press this button and the indicator will turn red. Press it again and the indicator will turn off. Next is the ground block. This will turn red after applying the block to the ground. Pressing this button will block your ground settings. Press again to turn this feature off. Ground block is typically used for switching in and out of service or switching through one of these reclosers. Recloser blocked. This feature blocks the multi-shot operation, causing it to only go the one operation before lockout. Press once to turn on. The indicator will turn red. Press again to turn off. You are now back into normal programmed lockout operation. Alternate Settings 1. This will apply a different set of settings to the control for back-to-back setups or various other applications. Counters. Pressing this button will display the total number of operations performed by this recloser and each individual number of trips per phase. The display will then return to the default screen. Battery test. Pressing this button will perform a battery test, and it gives you its functionality. Program 2. This is typically not programmed. However, it is possible to set a different metering scale if desired. Hotline tag. Pressing this red button will turn on the hotline tag. This will give you one shot until lockout. The indicator will turn red. Pressing the blue off button will turn it off. The indicator LED will turn off. Next are the red close and green trip buttons. When the unit is closed, the closed indicator will be red. Pressing the open button will activate its green LED indicator. There are advanced menu settings available. However, in most cases, these are only used for testing purposes. To access them, press the Enter button, which provides a meter display. Press it again to display load, and once more for load values. Pressing the Clear button will move back through the previous displays until you return to the main menu. Pressing the Counters button will give you the total and individual phase counters.